Hello, everyone. We're excited to introduce the Cyprus Digital Twin, a transformative platform designed to revolutionize how we understand, manage, and protect critical infrastructure in cities. Imagine a digital twin of an entire city, a virtual representation that mirrors interconnected systems in real time. This allows us to simulate potential disruptions, test different responses, and better understand how to manage critical infrastructure. Why does this matter? Critical systems like power grids, water networks, and transportation are interconnected. A disruption in one can ripple through others, threatening safety and disrupting lives. The Cyprus Digital Twin helps predict and manage these cascading impacts before they happen. Now let's take a closer look at the concept and explore how it works. The Cyprus Digital Twin is a powerful platform supporting the management of interdependent critical infrastructure systems. It helps assess cascading effects of both natural and man-made disasters on daily life, safety, and well-being. It integrates various infrastructure networks, including power, water, transportation, and telecommunications, while also assisting first responders. The platform collects data from multiple sources, such as IoT sensors, geographic information system data, open data, and historical records, using advanced data storage technologies. By incorporating high-resolution simulations and tools like EPANET for water and SUMO for transportation, the platform models interdependencies and allows users to explore different scenarios. A user-friendly interface helps decision-makers conduct what-if scenarios, assess risks, and make informed decisions to improve resilience. The architecture of the system is built to enable real-time data collection, simulation, and decision-making. Let's look at the key components. Data is gathered from diverse sources, including IoT devices across various locations, CIS testbeds for research and development, national and EU open data repositories, GIS data, such as OpenStreetMaps, the Cyprus National Access Point, centralizing transportation data, closed datasets from partners. A robust data collection system processes this information, including CIS IoT platform for central IoT data, MQTT protocol for real-time data streaming platform for high-frequency data, HTTP collectors for web data. Data is stored and managed in a data warehouse, featuring a data management system that organizes and arranges data in a way that makes it easy to access and use. A data lake holding relational GIS, time series, historical data, as well as models and scenarios. A GeoServer helps visualize and process spatial data. At the core of the system is a set of integrated services that enable seamless data interactions, processing, and decision-making. This includes REST APIs for seamless interactions, a backend managing core functionalities like authentication, data processing, and services handling, a services management system with Celery Orchestrator, RabbitMQ for task queuing, and Celery Workers for task execution. The system also includes a services repository with simulators, algorithms for predictive analytics, solvers for system optimization, and analytics for insights. Security is ensured through an authentication and authorization module, limiting access to verified users and systems. Users interact with the system via a human-machine interface, which includes digital twin interface for scenario development, decision support applications for risk assessment, and key performance indicators, real-time analytics for continuous monitoring. Now that we've covered the platform's architecture, it's time to see it in action. Let's jump into the demo and explore its capabilities. Hi everyone. In this video, we'll explore the Cyprus Digital Twin platform. After logging in, you'll see a dashboard with an overview of active scenarios and their statuses. On the left, there is a menu with options like New Scenario to create scenarios, Tools to use available tools, My Scenarios/Tools to view your work, Data for datasets, and APIs to extract data. Now, let's take a look at the Data tab. In this section, we have several options. We'll start with the Datasets option. Here, you will get an overview of the available data. You can use the search and drop-down menus to narrow down your search. When you click on a specific dataset, you'll see details like the source and the date it was last updated. Next, let's look at the Datasets Maps page. Here, you'll see an interactive map of Cyprus. On the right, there's a menu that organizes the datasets by category and appear as points or shapes when selected. Now, let's turn our attention to the Buses Map option. This shows live bus locations across Cyprus. The map updates every 10 to 15 seconds. Clicking on a bus reveals its route, stops, and speed. Moving forward, we'll look at the air quality in Cyprus. Here you will see all the sensors' locations on the left and pollutant levels on the right. If levels exceed safe limits, you'll get a real-time alert. By scrolling down, you can also view historical data to track changes over time. Lastly, in the weather section, you will see all the sensors' locations on the left, and on the right, you can check temperature, wind speed, and other conditions. If readings go beyond safe levels, you'll get a real-time alert. Scrolling down lets you explore historical data to track trends over time. Now, let's move on to the New Scenario option. Scenarios are grouped by domain. So far, we've implemented 3 scenarios, 1 for power and 2 for the water domain. First, let's dive into the power domain. In this domain, we have a scenario called the Power Network Resilience. This scenario shows how extreme weather, like windstorms, could affect power systems, predicting which lines might fail. Now, moving on to the water domain, we have 2 scenarios that help understand how new infrastructure or changes in demand might affect water systems. The first one, Water Network Resilience upon new development, user-defined DMA. Lets users set up their own areas for analysis. The second, Water Network Resilience upon new development, predefined DMA, works the same way. But instead of setting up a new area, users can choose from existing water networks available on the platform. Now let's talk about the Tools section. Similar to the New Scenario option, tools are grouped by domain. So far, we have implemented one for the water domain called Pipes Length. It calculates the total length of pipes in an area and breaks it down by pipe size, helping with planning and maintenance. Under My Scenarios/Tools, you will see all the scenarios and tools you've run, along with their status and results. For example, in the Power Network Resilience scenario, you'll see a visual of a storm affecting power lines. Finally, the APIs tab allows you to use and download data whenever needed. That wraps up our overview of the platform. Thank you for watching. As you saw, the Cyprus Digital Twin is more than just a technical innovation. It's a vision for urban resilience. By creating a virtual replica of critical systems, it enables us to simulate, assess, and mitigate the cascading effects of disasters, whether natural or man-made, on vital services like power grids, transportation, and water networks. Beyond simulation, it also leverages the collected data for in-depth analysis and supports decision-making processes to enhance system resilience. Before we close, I'd like to acknowledge the team behind the Cyprus Digital Twin. This project is a result of their dedication, expertise, and collaborative effort. Thank you for your time and attention. We hope this presentation has shed light on the Cyprus Digital Twin's potential, and we're excited to continue advancing this important project.